Alright, you've made it to the end of another section of videos. This time around, you've got Object-Oriented Programming 1 under your belt. But, do you really understand everything we covered? Well, here we are at another knowledge review, with the goal being to find out. Now, we've been working on this Bouncing X application. We've made it basically have a character that bounced around the screen, and then we went back in there and we showed you how you could put a list in and then introduce multiple characters bouncing around the screen. It was definitely pretty cool, but there's a lot more that we can do to the application. So we've decided to go ahead and add more features to that application in the knowledge review. So this time around for a knowledge review, instead of writing really simple programs, you get to go back to Bouncing X's and modify it so that it meets our requirements. So we've got 3 challenges lined up. Now let me go ahead and warn you, these challenges are going to require just a little bit more thought than what you've had to do with any of the previous knowledge reviews. Don't let this cause a panic. Just do the best you can. Remember, with each knowledge review, the goal is to ratchet up the tension just a little bit. Make it just a little bit more complex in figuring out the result. So, with challenge 1 of the 3, let's go ahead and start discussing what we're looking for. So right now, we have got a simple character that bounces around the screen. Actually, we've got multiple characters that bounce around the screen. What we're looking for you to do is give the characters some health. Let me show you what I'm talking about. Let's go ahead and come over here and bring up a whiteboard real quick. There we go. Now, here's our console window. Here's our X. And he's bouncing around, right? And he bounces around forever at the moment. We're looking for you to do the following. We want our character to actually have a health data member, okay? And we want this health to start out at a value of 100. Now, as the character bounces around the screen, each contact with a wall is going to cause damage to your character. So as soon as our X hits the wall down here, what we're going to see is 10 points of damage. So every time we collide with the wall, we're looking at 10 points of damage. So we'll start out with 100 points, and then suddenly it'll become 90, and then 80, and at some point, we're going to hit 0. Now, when your X, or character, hits a value of 0, at that point, what you need to do is eliminate him. He needs to simply be gone. I don't want to see the character bouncing around the screen anymore. So that's what we're looking for you to do in challenge number 1. Now don't rush into this. Think about it. I mean, obviously, the first thing you're going to want to do is just throw a data member in for health, initialize it to 100, and start subtracting away in the bounce collision area. But think very carefully about what's taking place in the loop and everything, just so you don't make any obvious mistakes. Now, you should be armed with everything that you need in order to pull off this challenge without any sort of difficulty. So with that, let me go ahead and hide this. And, well, you know what? Instead of that one, how about we hide this one?
There we go.
And this one. And then let's go ahead and switch to the pause now. So guys, go ahead and pause the video and then see if you can do it. Once you have got a solution, go ahead and come back, unpause the video, or restart the video if you happen to have stopped it, and see if your solution matches our solution. Okay, so by now, you should have come up with something, and if you haven't and you just let the video play, come on, go and try it. So with that, actually, without me going anywhere, Logan, let's just go ahead and jump right on over into Visual Studio.
All right, we'll bring up Visual Studio, and here we have the Bouncing X program from the last videos.
Okay, let's go ahead and run it, see where we're at. Just as a reminder, Logan ended off with a whole bunch of different colored X's bouncing around the screen. Looks wonderful. But let's go ahead and close that out and start adding in the ability to kill these guys via health.
Okay. Well, let's jump over to our box class, and let's give ourselves that health field we were talking about. I'll make this a private int, and we'll call it health. Now, we specified that we want health to start out at 100 for each of these bouncing X's. So instead of initializing it to a hard-coded value, like such, what would be better would be to have a constant representing default health, so that if we ever want access to default health later in the code, then it's easy to retrieve.
Sounds good.
So let's make ourselves a constant of type int called default health. And we'll set that to 100. Then anywhere else in code where we need to refer to default health, we can simply use the constant.
Plus, if we need to change the default health later on, it's easy. We can just do it right there.
Right, one place to change.
Okay.
All right, this gives us a health field, but we also need a health property so that if we happen to be in code outside of box, we can still retrieve the health.
Now, obviously, we don't want to be able to set the health.
Right,
we want to be able to read it.
Right, we want to maintain good control over health so that nothing ever manages to throw health out of range. So what we'll do when we make this property is make it read only. So I'll jump into the properties region and make a public property for health. This will be a public int health, and we are only going to add a get accessor. And get is going to do a simple return of whatever the health field is. So we'll simply return health, and that takes care of our health property.
Okay.
All right. Now that we have health accessible as far as reading it.
And not only that, it's getting initialized to a value of 100 when he starts out.
All right. Well, now we need the ability to take damage.
Okay.
So I want to have take damage work as a method so that we are allowed a check, and also it would make sense. That's an action we apply to a box as we tell it to be damaged or take damage. So what I'll do is jump in below our draw method and make a public method called take damage. And in take damage, I'm going to take in a parameter for how much damage. And that'll be a parameter of type int called damage. And when we're taking damage, we need to take our current health and decrement it by whatever the damage amount was. So health minus equals damage. Now, in order to keep health within range, we want to make sure that health does not go negative. So this can be a simple check of after we set the health, we make sure that if the health drops below 0, we need to clamp it at 0. So I'll simply set it back to a value of 0. Okay. So if the damage somehow results in negative health, we check for that scenario and simply lock the health to 0.
Fantastic. Now what we need to do is call upon take damage. Where would we do that from? Well, every time we collide into a wall, we need to take damage, 10 points of damage. So here we are inside of the check wall collision, and we could, in each of these positive collision checks, place a call to take damage. But what if later on you end up in a scenario where you want to add something additional, like make noise or spawn other characters or who knows, whatever. Well, now, instead of making a call straight to take damage, since we are adding in functionality for all of the collisions, meaning all 4 walls, how about we make a call to another method called something along the wall of process wall hit or something like that. And then inside that method, we could start stacking on calls to every specific method that we want to have some sort of functionality occur when the item hits the wall.
All right, it gives us a good generic area for code to go for in any case where a wall is hit.
Because we don't want to just keep putting it in check wall collision. Check wall collision would duplicate that code 4 different times, and we don't want to do that.
Right, this will limit the amount of code that we have to duplicate. All right, so let's jump in right after check wall collision. Let's make a new method, a private, new private method. Doesn't return anything, and it's called process wall hit.
Okay.
Inside of process wall hit, right now, we need to have the parentheses. All right, inside of process wall hit, we need to take damage. So we'll call upon take damage, feed it 10, but it would probably be a better idea to have a constant instead of plugging in an exact number here.
A magic number, exactly. So let's go ahead and do that real quick. We'll jump on up to the top.
Let's go right after where the constant for default health was defined and make a new constant for wall damage. So that we can say that wall damage is 10. Then later in code, in take damage, in process wall hit, we simply take wall damage amount of damage.
Sounds good.
All right. Now, of course, we need to remember to call process wall hit from within our check wall collision when any collision occurs. So this is in each of the 4 checks to see if each of the 4 walls was hit. So let me jump down inside each of these and add in a process wall hit, or call to process wall hit. So that takes care of X, and X being greater than Y, otherwise, so that we have vertical taken care of. And there we go. So at this point, I'm going to build to make sure that everything is working properly. Good. And the build's exceeded.
And we can go ahead and put a breakpoint in here, and we can test it out. Let's go ahead, and here's one way we can do it. Let's eliminate, at the moment, let's just go ahead and comment out the loop and focus on just the one character. Because remember, you've got the one blue one.
Right, there's a loop. Yeah, we've got the one blue one, but then we also have a loop that creates 15 more.
Exactly. So let's comment out the loop. And then let's go and set a breakpoint in take damage so that we can see every time the blue character slams into the wall, we'll jump into here and we'll be able to monitor what's taking place with health.
Okay. First, let's take out that loop that generates 15 other random boxes. So this is the loop where we had all of our red, yellow, and white boxes. So I'll simply comment out that entire block of code. Now let's jump back into box and set a breakpoint just inside of take damage so we can monitor what happens to health before and after damage is applied.
Sounds good.
All right. Let's build, and then let's run. So there's an X, and ooh, there's a collision.
Boom, he hit the wall, and here we are, inside of take damage. So everything worked properly inside of check wall collision, meaning when a collision was detected, it then called the process wall hit, and then process wall hit called take damage, sending in some damage. So now we can actually see what's happening. So let's check what health is currently equal to. 100, which it should be, because it hasn't collided with anything up until now. And let's see what damage is going to be. 10. So, of course, as soon as Logan steps past this, health is going to decrement down to a value of 90.
All right. So we'll jump over this line, and then we have a health of 90.
Exactly. So now if Logan goes ahead and continues execution, you'll see that the character will continue to run until it hits the next wall. Bink! Now you hit the next wall, and here we are back inside take damage. And, of course, we start out with a health of 90. Go and step over. And now health is equal to 80. So we can see that health is indeed dropping down. And it's going to continue dropping down until it hits 0. And every time after that, it's going to take 10 points of damage, placing it at negative 10. And then Logan's if check right there will always set it back to 0. So we're going to keep it clamped at 0. That's the first part of the challenge. The second part was to eliminate the item the moment that it ran out of health. Okay?
All right, I'm going to go ahead and cancel this out with Shift F5 to stop execution. And we can also take away this breakpoint because we're done testing health. Now, we need to have the X's die when they run out of health. And in this case, what dying means is that they get taken out of the list of boxes. That means they stop being updated and they stop being drawn. And then for all visual purposes, they go away.
Well, think about it. Yeah, for all visual purposes. I mean, it's very easy over here. And not only that, the garbage collector will come in and end up taking it out as well for the simple fact that nobody's going to be referencing it because it was being held within the list.
Right, and the list was the only thing referencing it. So once it's
So it'll get truly killed, but, you know, it's just whenever the garbage collector feels like doing his bit. But because we're going to remove the box out of the list, think about what happens. Basically, once it's removed, what happens when we come through the loop? Well, we clear the entire screen. So the last iteration of the loop, which had drawn the character striking the wall for the final time, so we saw the character there, the next time we come back through on the loop, we clear the screen so that erases him, and then we walk back through the loop, but that item needs to be out of the loop. If the item needs to be out of the box's list. So if the item is indeed out of the list, we're never going to call on update for that box or draw for that box, which means he'll never be drawn again. So as far as the user sees, the item just got eliminated. And then, like I said, since no one else references that particular item, the garbage collector will come by and clean them up afterwards. Okay? Now, how you want to handle this in the loop is the fun part, because you got to think about this because you can get in trouble quickly. For each loops are very easy to break, aren't they, Logan?
Well, if you change the enumerator, basically if you change the collection that the for each loop's on, that will break it. It doesn't allow you to change the collection as it's looping.
Well, let's do that.
So if we attempted to change the collision, let me begin with the logic necessary to see if a box needs to be removed.
Okay.
And I'll put this check right after update, because update is going to potentially call take damage if a wall was indeed hit. So right after we update the box, we can do a check on health and see if it dropped to 0.
So basically say if that box is .health, now we're using the property health.
And this is why we needed the public property in order to monitor health.
Exactly.
So if that health is indeed equal to 0...
2 equals.
Equals. And I won't bother checking for less than, because we've already got code in place to ensure that that never happens.
Precisely.
So we'll do a check to see if we've reached a health of 0. And if we have, then we need to have something happen. We need the box to die. And that will be accomplished, as we talked about earlier, as being removed from the list. So we'll say boxes are list dot remove, and we'll feed it the current box to remove. All right? So this should result in several bounces. We reach 0, and then this gets called.
Okay.
So
you can definitely see problems already, because what happens next, the very next thing we're going to do is tell the box to draw, but we've just removed the box from the list. Let's go ahead and run and start watching all the problems we're going to create.
All right. So we begin running, and there's a bounce. 2, 3, 4, 5, 6, 7, 8, 9.
Here we go.
Last bounce 10. And we get an exception. The collection was modified. So we cannot change the box's list as long as we are looping upon it in a for each loop.
That's right. So we need to take another approach. How about using just a simple for loop where we have our own index variable that we can control walking through?
Okay. Well, let's change this over to a for loop then. We'll take out the for each and we'll replace that with a simple for loop where we have our own index. We'll call it I, and we'll initialize it to 0. Now, we want to keep looping as long as there is some other box in the loop to move on to. So the check will be as long as I is less than our boxes dot count. And then for each iteration of the loop, we'll simply increment I. So we continue walking through boxes. Now we do need to change how we refer to boxes. Since the for each set us up with a simple variable that we could use to access each box, in this case we don't have such a variable. We'll have to address the boxes list directly. That means taking out box here, replacing with boxes, and then specifying an element that we want to view. This is going to be represented by I, because I is used to walk through all the boxes. So I'll take this and jump through the rest of our cases where we check box and replace it with boxes I. Except for the place where we remove from the list, I'll simply change that over to remove at, since a list can take in an actual index to remove, and we'll feed it I. Instead of saying boxes.remove boxes I, just remove at I, simply.
Now, hopefully, looking at this, you can see that we definitely have some problems with our logic. Once again, we're going to be removing a box and then turning around and drawing a box. But are we going to be drawing the box that we just removed? No, when we remove this box, all the items in our list just shifted left, so we're drawing the next box. Plus, we can also end up with other issues here as well. Well, in this case, to be honest with you, I think it's going to work quite well.
Because we've only got one box. You're saying a shifting problem, but with one box, will we really hit that?
And visually everything's going to work great, but we're going to have another problem when we introduce multiple boxes. But go ahead and run it real quick.
Okay. So we're running. Now we're bouncing 1, 2, 3, 4,
60,
5,
50,
6,
40, 30.
7, 8, 9. Last bounce.
And boom. And here we go. So go ahead and watch this. Take a look at what I is. I is 0, right? Because there's only one item in there. This is what I was talking about. What happened? The one item just got removed. We turned right around and we tried to draw. There's one item. Can't draw it. We now have an out of range scenario. So we need to change our logic around just a little bit. So what can we do to do this? Well, there's several different approaches. You want to just continue right here so we skip it, Logan? Which approach do you want to take? There's so many at this point.
Let me break out of this first. All right. Now, just for looking at it from a logical stance, a continue would be a good idea here, because once we've determined that the current index needs to be deleted, we want to make sure that nothing else happens for that specific index, and that would be a very good place to use continue. So I say, we're saying that we're done with this box. Let's continue on to possibly another box.
That meaning we're now done with this iteration of the loop. Let's go ahead and continue with the next iteration. So remember what's going to happen. Continue is now going to cause us just to skip over anything else in the loop, jump back up here, increment I, and then once again do our test. So let's go ahead and run this.
90, 80, 70.
60. I think I might be a little lower than you.
Maybe. We'll see.
Oh, it's coming up. Here comes its moment. And boom, there you go.
So the X gets killed, but the program continues running.
All right, so everything looks great here visually, like I was saying a second ago, but that's with one item, as you were saying. Now let's put a few items in there.
Do you want to bring back that loop that had 15?
Or just with the loop, maybe do this. Only have it add 4 items. So remove 2 of those add random boxes from inside. And then change, delete those out and then change the I to while I is less than 4.
Okay.
So we've got 4 different red boxes and a blue box.
All right. So now if we run, there's our 4 red boxes and 1 blue one.
Bouncing around. Ooh, people are disappearing. 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 Ooh, it all works so great. But did it? That is the question here. We still have a flaw in the object. The moment we start dealing with more than one item and we're looping through things forward, we definitely introduce a very interesting scenario. Let me come over here and show this to you, if you guys don't mind. So we'll just jump up here for a second and bring the visibility back here. And we'll just remove everything. Let's say that our list looks like this. So let's say that we have 0, 1, 2, 3. So we've got 4 items in the list. And let's say that these items are, of course, we know they're boxes, but I'm going to give them different characters. A, B, C, and D. Let's just say that's the character we see bouncing around so that you can see what slot they are in. Okay, so now we start out, and with our loop, I starts out as 0. And remember, it is going to move in a forward direction because we're using I++. Which means we're going to start out right here, and we're going to walk in this direction addressing our objects. So let's just say that we just performed the check on object A, so in index 0, and his health was okay. It diminished, but he's still above 0. So what happens? I now becomes 1. So now we're pointing right here, and B collided with a wall, and it was the last of his health. So we go in there and we eliminate B. We remove B from the list. Okay, so B goes away. Actually, you know what? Let me draw it like this. So B goes away, but what happens automatically? We have a shift. C comes down to here, and D comes down to here. Okay? So we removed it, but then after removing, what did we do? We did a continue. If we wouldn't have done a continue and instead would have done a draw, let me go ahead and jump back over to the code real quick. So if we would not have had the continue in there, we would have done this line of code. Who would we have been drawing? We'd have been drawing C, not B. B's gone and everything's shifted down. And since we haven't changed I, we're looking at C now. But we didn't. We continued, so that was good. So what happened to I? I incremented again. So I just became 2. So we moved once again. We're now looking at this guy. Okay? We're looking at D. So we tell it to update and all that good stuff, and that's all good. So we managed to truly update A, we truly updated B, and we truly updated D. But what happened to C? This particular item in the list got skipped over because of the way that the logic is designed at the moment. Not good, eh, Logan?
No, especially if you had a scenario where everything had to stay in sync, or even just for a level of choppiness. We couldn't tell in the console app, but let's say we had a smooth 60 frames a second. This could have introduced a chop.
It could have.
But I mean, in general, we have a loop, and its purpose is to update everything every iteration. And now we've created a scenario where things can be skipped on certain iterations.
So not good. That's what I was talking about a second ago as we were going into this. Visually, we could be in a scenario where everything looks good, but up under the hood, it's not really running right. And it did look good. It looked like all the items were being removed, and finally they all died, and everything was great. But everything wasn't great because we had items getting skipped in the updates when somebody got removed, and that was not a good thing. So we need to correct this. So at this point, Logan, you up for doing the reverse loop?
Sure.
So what happens if instead of starting off right here, let me erase some of this out just to make this a little easier to see. What if instead of starting out with I equal to 0, what if I is equal to our count minus 1? So let's come back up here. Let's update this just a little bit. So up here, if we say I is equal to our boxes dot count minus 1. All right, first of all, for anybody that's confused with the fact that we're using minus 1, let's take a look at that. How many boxes are in the list? 1, 2, 3, 4. Okay, why do we want to say minus 1? Well, if we didn't say minus 1 and we basically ran from 4 down to 0, well, we're going to have a problem. We don't even have a 4 to point at. So if we said minus 1, that would point at the right guy because 4 minus 1 is 3. So that would start out with the last guy in the list, which is what we're looking for. So this will work out great. So now if we come in here and basically let's add in this just like we did with the example a second ago. I is going to be decremented each time. So now if we come through here, we're going to start out with D. So I'm going to update all this just a little bit. I just really want you guys to see what's happening here. Anyone who's 100% with me can simply fast forward. Well, let's just rewrite that. Okay, so we start out with D, and we do our thing with D. All is good, and everything's happy. So then what happens? I decrement. So where I had started off at a value of 3, I now becomes 2. And hey, what do you know? We're now looking at the right guy. Our loop's running this way now. So we've done with D. Now we're looking at C. Oh, we need to kill C, because C just hit a value of 0 in its health. Not a problem. And what happens the moment that we kill him? D shifts down here. Now what do? If we continue with the same type logic that we have over here right now and just continue, right? Think about what happens. I gets decremented from a 2 to a 1. We come down here and look at B. So D slid down to, well, the next available spot, which is it was supposed to, since C got killed out of the list. And now we're down here looking at B, and we didn't do anything wrong with D. We didn't skip anybody. The logic now worked right. So at this point, here we are at 1. Let's say that we needed to kill out B. What would happen? B gets killed. D slides down to slot 1. But since we continue, we come back up here. We decrement I, so I now becomes 0, which moves us on down, and we're now looking at the very first one in the list. So as you can see, as we're killing out items, all the other items just slide left, and everything continues to run properly. Everything's in sync. We don't skip anybody by accident. Okay?
Right. Whenever we delete something, any remaining items shift down into that slot.
That's right.
But at that point, we're already done with that slot. The next thing we do is decrement. So even though the shift occurred, we move away. We move on.
That's right. So let's go ahead and implement the reverse loop.
All right. So back to code now.
You want to show them the code snippet for it?
We could even go ahead and show the full code snippet. Of course, the idea is here we're moving something like this over into the initialization, and then basically it's almost like swapping these two in a sense.
Yeah, more or less. And then take the plus plus and make it minus minus.
But to make that even easier, there is a code snippet in place. So 4 with 2 R's, and then tab twice, and we begin with our initializer, instead of being 0, is a length minus 1. I'm fine with the variable being I, so I'll simply tab over, and for length, this length is instead boxes.count. And the template, the code snippet, already has -1 in place for that. So even though count is a count, we want to change this over to an index that's 0 based, so we take 1 away. Then the next part of the check is to continue looping as long as I is greater than or equal to 0, and then decrement I, so that we reach a value of 0. So all that looks good. I'll hit enter, and I'll discard this entire block and simply cut this new beginning of a for loop and paste that over the old one, and then erase the rest of the block out altogether.
Okay.
So I've simply replaced my other loop with the new reverse loop. And everything else was already set up to take into an account an I index, so we have our boxes I. Everything else is the same. We still have our continue logic. So everything looks good. We should be able to build and run. So there we have some X's. They're bouncing. The faster one should be dying soon. And there we go. There we go. And everything still works just fine.
Very nice. So that is the result that you should have had, or at least had something similar that gave you the same result that we have, but just make sure when addressing your loop that you were careful to think about the skipping possibility. If you have multiple on the screen and you never tested it with just one item to begin with, you would have never seen an out of bounds. But there would have definitely been a problem, and that problem would have been the fact that one of the items got skipped every time somebody got removed from the list, and that's not good practice. So, well, obviously it's not good practice. So here the reverse loop allowed us to take care of that problem, and everything worked right. Okay, so that was that challenge. Hopefully that wasn't too bad. You can see we've got you in there thinking just a little bit more now. It was kind of a tricky one because it starts out sounding so easy. Just throw in a health and make the health go down as it slams into the wall, then remove it when it hits 0. And, of course, the first thing you think is, oh, that's easy. Property, data member, and an if statement. Woohoo! But it did get a little bit tricky. Now, let's see if we can make things just a little bit more challenging. So let me go ahead and jump back over here, and we will hide out this guy and this guy, and let's turn our pause now back over to knowledge review. For anyone that happens to be fast forwarding with the track bar, they'll now see that they're at the next challenge. This challenge right here is going to be loads of fun. We're going to require you to do a little bit of research. Now, what we're looking for is the ability for the user of your application to inject characters themselves. Meaning, I don't want to have a for loop creating all of these boxes. Let's make it interactive. Let's create a scenario where the space bar becomes an injector. Meaning, if you tap the space bar, a box is suddenly created. You tap the space bar 5 times, you now have 5 boxes created. And those boxes are random boxes, all moving in their own random direction and all that good stuff. So, all you have to do is just look. Research. That is going to be required here. We have not walked over the specifics of how to do something like this, but I can assure you with probably 15 minutes worth of research, you can pull this off. Now, this is very important to me, and to Logan as well. Why? For the simple fact, when you get out there and you start writing your own applications, you're not going to have a tutor sitting there saying, all right, we just covered this a few minutes ago on the whiteboard, now do it. You're going to find yourself in scenarios where you're going to have to do research in order to figure out how to make something happen. So that's something we're slowly going to start adding more and more into these knowledge reviews. So in this case, you need to find out what's required so that a user can hit the space bar, and every time the user hits the space bar, that is what is responsible for creating a new bouncing character. Get your for loop out of there, okay? So with that, let me go ahead and bring up the pause now. And feel free to do that. Go ahead and pause and knock this challenge out. Now this one's a little bit more challenging because research is involved. Once you have it complete, come back and see if the way you do it is the way that we do it. So go ahead and pause. And welcome back. As you saw, it wasn't that difficult. And if you did have trouble with it, just kick back, relax, and watch how we do it here. So Logan, let's go ahead and jump on over.
All right. And let's take a look at what we need to do in order to get key presses while the game is currently running. Now, the first thing that would come to mind is we have done input things with console. Now, if we look inside of console, under read, because we've done read lines before, and right above read line is read key. And that seems useful because we're looking for a key press.
Exactly.
So what comes to mind is to do a console.readKey. And what does read key return? It returns a console key info. So of course we want to store that to see what it was. So we could do something like a console key info with capital console.
It's further down.
Key info.
There it is.
Well, let's call this variable key info equals console.readKey.
Because again, as Logan just pointed out a second ago, console.readKey is going to return, as you can see right there, the console key info. So a type of console key info, our variable name, is going to hold the results of the read key. Okay?
So the next thing that we'd want to do is to check that key and see if that key contained the space character. So we could begin an if statement and say if keyinfo.key is equal to console key dot spacebar, then we know we want to add a new X into the boxes list.
Okay.
So that would be a boxes dot add, and for the box, as a matter of fact, instead of directly addressing boxes, since there's multiple lines involved with making a new box, let me just use the add random box, since that's only one line we have to do. So we'll just call upon add random box, and let's say that the random boxes are going to be red.
Okay.
As a matter of fact, before we do this, I'll actually comment out our loop that we had that was adding 4 red boxes, just so that the screen is clearer when we begin adding boxes ourselves.
So you want to go ahead and take out the blue one as well?
I'll leave the blue one, just since
okay. So guys, just
keep
in mind there's going to be one blue one that we've injected manually.
But the spacebar should add red ones. And all of this looks like it should work. I mean, we're getting a console key info, we're checking to see if that key info was spacebar, and if it was, we're adding new boxes.
But if you were able to follow along, you're going to know that at this point, looks can be deceiving. Let's go ahead and build.
Or build and run.
Build and run.
Now look what's happening. We don't see anything. And this is why I wanted to leave that blue box, is we should be seeing at least a blue box running around.
Mm-hmm.
So, well, even though we don't see that, let's start adding boxes with the spacebar. So, I don't know if the capture will pick it up, but there's small flickers every time I add the spacebar. So you can kind of follow the blue box as he slowly runs, and then each flicker there's more and more red boxes. As a matter of fact, let me hold the spacebar down for a second. We see everything's adding, but then everything goes away.
Okay.
So let's take a look at what is actually happening. Well, what's going on here is the read key is actually holding up execution until a key is pressed. So what happens is, as we enter this loop, we clear the console, and then we look for a key, but we stop right here until a key is pressed. So until the spacebar, or until any key is pressed, we are just sitting at a blank screen. When a key is pressed, we add a new box, we get a red box in addition to the blue box, then we draw things as necessary, and that's where we get that little flicker. The flicker lasts for however long we're waiting, then we clear the screen out and start waiting again.
Yeah, so we need to come up with some way of checking to see if a key press is available.
Right, in order to continue or to keep the loop running when a key isn't pressed. So it looks like the key presses just go along with the running of the game instead of freezing it like Hyperion. So we need to do a check, as obviously we can't do a check on read key every line, because any time we do a check and there's no key, we'll freeze.
Right.
So let's do a check and see if console dot key available is set. So if there's a key available, then do the check. So I'll put this check around everything, so around the console key info and the adding of the box. So only if a key is available do we go in and read that key, and then turn on and check that key to see if it is a spacebar. That way, if no key was pressed, we don't stop. We continue running. So anytime a key is not pressed, the program runs normally.
Exactly.
Now if we run, there is our default blue X, and the program continues to run. So hitting spacebar results in a red X. Hitting spacebar again results in another one, and so on. And you can see as these continue bouncing, our health is still in effect, so they eventually die off. So now I can hit the spacebar a lot, add a bunch of X's, watch them for a while, and then after a while they should all die.
Very nice.
So there we go.
So that is what we were looking for Challenge 2. Anything you want to add to that, Logan? I think that pretty much covers it.
Not really. I mean, it was just the tricky thing was the fact that read key held up execution, and we had to find a way around that in order to keep the program running.
Exactly. Now, let's blow their minds. Our final challenge. So we're going to jump back over here real quick. We probably have somebody right now going, oh, it was already hard enough. Yeah, we're going to make it really interesting here. So let's go ahead and turn that off and this back on for anyone that's using the trackbar. All right. For the final challenge, what we're looking for you to do is inject the ability to have the characters a specific color based on their health. And this color, of course, is going to handle itself, if you will. Let me go ahead and jump over to a whiteboard. I'm going to need a whiteboard to draw this out. So we'll just come on up here, get myself something to work with. Actually, let's just throw another whiteboard up. All right, we have a health that starts out with a value of 100. And that health is going to go all the way down to 0. So what I'm looking for is to take that health and divide it up into thirds. So I'm just going to get approximate numbers right here. So we're going to start out at 100. So about a third. And this down here is 0. So you have something like 0, 33.3, 66.3, 100. So just say 33 and 66, right? So I am looking for when the health is in this area. I want the character to be green. When the health is in this area, I want it to be yellow because, well, it's getting close to dying. And when it gets down here, it needs to go red because we're going critical. It's just about to die, so we need to know it's about to croak on us. So this way, as you got a whole bunch of characters that are bouncing around the screen, just by glancing at it, you'll know who is about to die and who is not. Okay? So, green, yellow, red. But here's the kicker. There's some rules that I have for you. you cannot use any if statements. Okay, does that sound fair to you, Logan?
Right. Yeah, no if statement check, because what that's going to do is bring up a very static and hard-coded method of doing this, where
which we're going to talk about that in just a second.
We've even mentioned that these values are approximate in the general area of the bottom third, middle third, and top third. We're not saying specific values, not between 33 and 66 exactly.
That's right. And here's the reason why. I was going to say this at the end, but I'll go ahead and throw it in now. These colors need to exist in a list. So you're going to have a list, and inside that list, you need to have the colors red, yellow, and green. Your application needs to just simply look at this list and say, well, we've got 3, so we're going to go by thirds. But if then for whatever reason you come in here and you say, all right, when we start out, it needs to be white first. So if you suddenly added this color into your list and then rerun your application, instead of having your thing divided up into thirds, now it's going to be divided up into quarters. So you'd start out with white, then green, then it would go to yellow, and then finally to red. And just think, all of that happened simply because you added one more color into the list. So if you add another color, well, once again, your application just divides it all up properly into fifths. So we need to be able to do that. Because of that, you can't use an if statement where you say, if health is greater than 66, then the color is equal to green. If health is greater than 33, it's going to be yellow, else if, you see what I'm saying? You can't do that. So you're going to have to think logically here and figure out numerically how you can work with the health number in such a way that you can basically pull an index result. How can you convert 0 to 100 into 0 to 3? If you can convert 0 to 100 into 0 to 3, and let's say that you ended up with a 2, a 1, and a 0, if you had that and use that as an index, wouldn't you start out by pointing, here's 2, then when you move to 1, then when you point it to 0, oh man, guys, I just gave you the answer, okay? So that's what we're looking for. Have your colors work this way and be able to simply go in there and add another color to the list or remove a color from the list and just relaunch your application and your colors work accordingly. So that is the assignment. Anything else you want to add to that, Logan, to make sure that it's exactly what we're looking for? Or was I nice and clear?
I think that clears it up.
All right, so with that being the case, this one is a bit more challenging. Play with this on paper first before you just start coding. That's my suggestion. It will make life a whole lot easier if you do that. Okay? So with that, let's go ahead and hide this out. And at this time, go ahead and pause the video and attempt it. Best of luck. Now, we know this is going to be challenging. Okay? Don't let that stress you out. In designing games, you're going to find yourself in scenarios constantly where you're fighting challenges. So go ahead and pause it. See if you can knock it out. If you can or can't, come back, compare your result, or watch how we've done it. So pause now. Logan, while they've got it paused, I say we add one more. Don't let me forget. But I like the idea of one more challenge just for the heck of it, and that's converting our boxes from characters to like that.
Okay, so a fourth challenge then.
A fourth challenge, yeah. Sound good to you?
Yeah, sounds good.
All right, fantastic. And welcome back. If you come in at the very end of a conversation Logan and I were having, don't worry about it. You'll see what we're talking about in just a minute. So, Logan, let us jump over to Visual Studio. And let's see. Actually, you know what? Thinking about it before we even get into that, let me pull out an example for you. Where's my... There we go. Hang on. You can't exactly hit F7 when you're inside Visual Studio. Let's do this. Add another sheet of paper. Let's talk for just a second with some drawing to give an idea of what we're looking for before Logan starts coding anything out. We know that we're going to have a current health. Guess the H wouldn't hurt. So let's say that our current health happened to be 75. That means if we had the scale of 0 to 2, that we need to be in the green region right now because that upper third is from 66 up to 100, right? So we have 75. Now, remember earlier when coding in the default health, Logan stored it in a constant in case we ever needed to get back to it? Oh, this is a scenario where we definitely need to get back to it. What we need to do is start out by finding the percent. So here we are, default health. And default health, our default health starts out at 100. If we divide it, 75 by 100, what are we going to get? Well, we'll get the percentage. And in this case, it's going to be, we're going to get 0.75, so 75% of our health is what we would have if we had a value of 75. If we were down to 50, we'd have 50% of our health. So now, what I want to do is take this and find out 0.75, so this is the mapping phase, if you will. 0.75 is basically what of 3, okay, if we have 3 colors. So we could take this and look at 0.75 times 3, because we have 3 colors, equals, and if you do the math, you're going to find that equals 2.25. So you can read this at the moment as follows. 75% of 3 is let's move this down just a little bit, 0.25. All right. That 2.25 looks like it could be handy. What if we were to truncate the 0.25? So if we truncated the 0.25, we would just be left with 2. Well, what does truncate mean? Well, what if I want to eliminate the decimal altogether? So let's think about this. And this is really starting to use a lot of the different things that we've taught you throughout the XNA Xtreme course, Volume 1 and Volume 2. So what if 2.25 was stored in a float data type? Kind of makes sense to me. It has a decimal, right? But what if we were to cast it over to an integer? What would happen? The 2.25 would simply have this cut off, and this would get stored as an integer, because an integer is only whole numbers. Wow, this is kind of convenient, isn't it, Logan? I mean, think about it. What do we have right here? 2. If we had colors 0 being red, 1 being yellow, and 2 being green. When we were at 75% of our health, what color should we be? 2. It should be green, and that is correct, because we said if we divide it into thirds, basically from 66 up to 100 is going to be green. But if we drop down to, say, 50, so 50 of 100 is what? Well, now we're dealing with 50%, aren't we, Logan? Hang on. Let's all do this. Let's all grab a calculator. We've got stupid simple numbers right here, right? So we've got 50 divided by 100. Listen very carefully to what I'm saying. So if you have a calculator, you'll follow right through. And as I said a few seconds ago, that's going to be 50%. So 0.5, right? Now let's move that number down here. So 0.5 times 3, hopefully you can see the answer, but let's just do it. So 0.5 times 3 is going to be 1.5. 1.5. I'll just put a 0 there. There we go. So 1.5. Now, if we took 1.5, let's move that on down here so that we speak this out. So 50% of 3 is 1.5, and that makes sense, because what's half of 3? 1.5. 1.5 plus 1.5 is 3. That's the whole half thing. Now, if we truncate the 1.5 so that we get the integer from it, 1.50. So we cut this off right here, and our integer is a 1, okay? What color would we be? Yellow. And what did I say? From 0 to 33, we're going to be red. That's a 3. And from 33 to 66, we're going to be yellow. And on up, we're going to be green. And look at this. That 0.5 falls right into this area, so we should be yellow, and we are indeed yellow. Pretty handy, eh? So this is what we're looking to accomplish. Now, by simply coming in here, let's just walk through this. By simply coming through and adding another color. So now we've added white in there. What's our count? Our count is 4. We can represent that with list, whatever the list name is, the identifier, dot count. So now there's a 4 in there. Okay? If there's a 4, what is, so once again we can do the same thing. We can do 0.5 times 4 equals 2, right? So we can come over here. Let's update all this stuff. All right, so now we've got 2. So now we've got 50% of 4 is 2. Well, it kind of makes sense. Half of 4 is 2, right? All right, so now what are we going to be pointing to? So 2, if we truncate 2, what's the answer? It's 2. So now we've added a little bit to our range here. So now we're going to be right at green, just about to change colors, huh, Logan?
Right, because since the range is larger, 50% happens to fall onto green instead of onto yellow.
That's right. But if we had gone down just a little bit, like let's say that we had, for instance, our health was at 25. So 25 divided by 100 is what? So 25 divided by, oops, hey, let's not do that. So 25 divided by 100 is going to be equal to 0.25, and I know I'm using very simple numbers. I just want to say this out loud so anyone that's not math savvy these days, because perhaps they've been out of school for a while, can grab a calculator and follow what I'm saying. So you've got 0.25, so 25%. So 0.25 times 4, so now I can say times 4, is equal to a value of 1. Okay, so here we've got 1 down here, so 25% of 4 is 1. Now it's turned yellow. And we're right there on the edge of yellow, too. So hopefully this will give you an idea of how we can come in here and dynamically change our color list up and down. And by doing that, as long as we take the count into account right here, we can more or less figure out exactly where we need to look at inside that list to grab a color based off of our health. Okay? Logan, does that make it pretty clear?
Crystal clear.
Okay, fantastic. Let's go ahead and code this in real fast.
All right. So now, jumping back over to bouncing X's, let's jump into the box class, and let's put our color list into action. Since color has now been internalized into box, I'm going to remove the external property.
Okay.
Since we've specified that all boxes always have a color range of either red to green or red to white, we don't need any mechanism for setting it externally. So I'm going to completely remove the color property, and I'm going to change the color field to be a list. So we'll still have a private console color, but this will be now a private list.
So a list of colors.
Of console color. And I'll change the field name to colors to represent the fact that there could be many colors. Now we do need some way of having this set up. Of course, I could initialize it to an empty list, but we'd have no way of adding items to it in the variable initializer.
Right.
So what I'll do in order to make sure that we can have these always spawn with colors is put in an initialize method. So we'll have a public void initialize. So,
INIT.
and it's like so, initialize.
And throw an I in there real quick right after the T.
And there we go. Yay for spelling today.
Okay.
Anyway, with our initialize, what I'll do is I'll create the actual colors list. So this will be colors, the field, is equal to a new list of console colors. And then add in the parentheses. And this takes care of the list creation. Now we can turn around and add colors to this list. So we can say colors.add. We want to add in console color dot red.
So we'll add our low color first because this will be at index 0.
Then I'll paste this 2 more times so that we can add in the color yellow and the color green. And that takes care of our 3 colors. Now I do need to remember to make a call to initialize outside of here. Now this initialize method is just one of the many ways you could have gone about doing this. For sure. Could have used a constructor or pretty much any other way that would result in colors always being created.
And constructors is coming up in the next section, and when it does come up, we will start using constructors for doing things just like this, initializing values when an item is instantiated.
Right. But because for now initialize is a simple method, I do need to make sure that a call is made to it whenever a box is created. This means first down here in add random box, right after we make a new box, I'm going to call upon initialize. So box dot initialize. Then anytime a random box is created, its color is or its colors list is set up. Now I'm also going to take out the color property, since if we try to build here, this is now an error. We no longer have a color property. So I'm going to wipe that out, and now there's no reason to feed a color into add random box. So I'm going to take out that parameter. Now that means we need to jump up to wherever we called add random box and take out the color as well. And again, when we make the one custom box.
Okay.
And one last place for color. Okay. The last error was actually inside of draw. And this brings us to the point where we now need to decide on exactly what color to pull out of that list depending on when health is set up. And I'm going to do all of this inside of draw. Since we need to specify a foreground color at this point, we need to put in the necessary logic to pull and convert health down to an actual color inside the list. So here we go with all that stuff that was just drawn on the whiteboard. First, we need to come up with a health percentage. Right now, health is in a value or range of 0 to 100, so it more or less is a percentage. But I want to make sure I handle this in such a way that no matter what the health max is and what the current health is, we always can pull back a 0 to 1 percentage as a float. And to make that easy to read, I'm going to store it in a variable called %. So I'll have a float %. We need to set that to whatever our current health percentage is. So this is simply health divided by default health. That will take our current health and convert it into a value of 0 to 1. Now, the only problem we have right here is that health as a field is an integer. Default health, the constant, is also an integer. So we will do integer division here, which means no decimal, which means our percent is going to be 1 or 0. We won't get all of the values in between.
That's right.
And having that precision is important here. We need this to be a float. So in order to have this division be run as floating point division, I'll cast one of the operands over to a float. If I cast health to a float and divide, then we will do floating point division, and we'll have our decimal place stored in percent.
Perfect.
All right, now that we have the percent figured out, we can apply that to the colors list in order to pull a color out. So that means we can make a color index. So I'm going to define an integer variable called color index. And color index is equal to something like percent times colors.count, because this gives us the number of colors we have.
Let me show them real quick. What was the first thing doing? First thing is grabbing what? Percent, exactly like we demonstrated. What was the second thing doing? It was taking the percent and multiplying it by the count.
So really, we're just following what's drawn up on the whiteboard in the code.
Exactly.
So the current color index is the percent times colors.count. But if we try to build this, there's a problem. This will result in a floating point number, which we're attempting to store in an integer, which can't be done explicitly. We can, however, cast, and that's exactly what we want to do. As we talked about on the whiteboard, that's exactly what we're going to do, is cast this floating point number over to an int, but we have to do that explicitly. So what I'm going to do is cast the entire result of this operation to an int. And I need to put parentheses around that to make sure that the mathematical operation occurs first, and we cast the result instead of simply casting percent or colors.count. All right. So this takes whatever values. So, for example, one of the values we had hit on the whiteboard was what, 2.25. If that was indeed the answer here, we would store 2 in color index. Mm-hmm. So now we can turn around and use that to pull a color out of the colors list. So down here, when we need to achieve a color, we can replace color with colors, and then give color index as the index specified for the list.
Don't let this startle you guys. This is exactly what we've been doing with working with the list. Just give it the list name and the index inside.
Now all of this looks like it should work at this point, and mathematically it does, but there's a small problem. What if we get a health value of 100%? Because we start out with health being 100, default health being 100, which will result in 1, so 1 is stored in percent. If we multiply 1 by the number of colors is going to be 3. There's our 3 colors. So we end up storing a 3 in color index, and the color range is 0 to 2, not including 3. So if we run this, we'll probably run into an error upon running. First, though, I'm going to build, make sure we've taken care of any errors, and we have. Now let's run, and immediately we get an exception. Actually, we get object reference of colors. Actually, we have run into a case where somehow initialize wasn't called. We've actually got a problem before the problem. Let's take a look at the code and make sure that initialize is indeed being called for all boxes, because initialize should take care of colors getting initialized. What do we have here?
A box that gets created without initializing.
Right. We took care of initialize inside of add random box. We did not take care of it inside of our one custom box. So let's turn around and initialize new box, and then that should take care of that error. And let's see, use of uninitialized. Oh, whoops. Let's make the box before we initialize it. There we go. All right. Now if we run, we get a different exception. This is what I was talking about a second ago. We have attempted to pull color what? Color index 3 out of colors, which only has 3 elements. And we can expand this and see. There's 0, there's 1, there's 2, there is no 3. So what we need to do here is actually cap the color limit, because if we had dropped anything less than 3, if we had 2.99 would have been casted to 2. 2 would have been valid. So what's happening is we're going just to the, call it the other side of 2 now. We have 1 that puts us out of range, and the easiest way to combat this is to simply clamp that value.
Right.
We could do something like we had done with the take damage check, just check for a value of greater than 2 and set that to 2. But I want to show another way of clamping the value. What I want to do is take color index, and we'll use the math.max operation to specify a maximum, or excuse me, a math.min to specify maximum. It sounds confusing, but in the end it works. We take math.min, so we get the minimum value between 2 other values. We know we want the minimum to be 2. We don't want to go over 2. And we want to specify the minimum between 2 and whatever index is, because index could go less than 2. Less than 2 would be desirable or usable. So the min of 2 and the excuse me.
Yeah, I'd swap that around. I was doing it
you
color.
had
I was going to do color index and then the count minus 1.
I see. I was about to have 2 and then color. Yeah, I see. So color index and then.
So basically, you're taking in the color index and you're saying make sure that it's min. It does not go above the count minus 1.
And it's tempting to put 2 into this case because 2 would work here. We know that we have 3 colors, so color of 0, 1, and 2 would be useful. But then we're forgetting about the requirement of having that list be changeable at any given time.
Precisely.
If suddenly we add another color, 2 is not our magic number anymore.
Right, it's not the upper end of the index numbers inside.
The real number we are looking for here is count minus 1.
That's right.
So that way if we had 3, that would result in 2. If we ever change it to something else like 4, then 3 becomes the desired number.
That's right, 0, 1, 2.
So we'll replace this 2 with colors dot count minus 1.
There we go.
And this should clamp the color index down so that if we happen to all the way reach 3, we still stay at 2. So we have 2 and then down to 1 and then down to 0.
Yeah, I mean, it's just going to prevent us from going above what we set as the maximum we can go, which in this particular case, the max that we're saying that we can go is a value of 2 because there's 3 items in there. Don't let that confuse you. Well, there's 3 items. Why are you saying 2? Because, again, when we translate that over to the index count, that's 0, 1, 2. There's your 3 items. 2 is the largest number we can point to.
All right. So let's run and see what this gives us. Ooh, a green X.
And he's losing health. And, he's
Change
yellow.
to yellow. A few more bounces. Change to red.
Oh, he's getting ready to die.
And that's it.
Oh, he's dead. Very nice.
So, yes, everything's working
Well,
now.
to prove it now, let's go ahead and add white as the final color in the initialize.
So let's add in a color for white.
So now we should go through 4 different colors in the life of the character. Starting at white.
There's white. There's green, yellow, red, and death. And all we had to do was to add a color to the list.
Very nice. All right, anything you want to add to that, Logan?
I'm half tempted to write this color index check as an if statement, just to show an alternate approach to it. Just possibly to make it make.
But we told them no
sense.
if statements, so.
Right.
But yeah, now you just have fun with it.
So just to show that, we're going to show what the min is doing. Another way we could have done this would be if color index is greater than colors.count minus 1, then color index is equal to colors.count minus 1. And this again mimicking the check and capping we had done back in take damage, where we do a check and then clamp it at that value if it's gone out of range. So we could comment this line out and run it just to prove that this is indeed working. So white to bounce, green, yellow, red, and death. So everything works exactly the same. Just pointing this out in case the use of math.min was confusing, this is all we're trying to accomplish, is to keep color index within the specified range. And math is a more in-line way of doing that, a more concise way of doing that. So that's just one alternate approach to the color index.
All right, very cool. Let's go ahead and jump back over here, and now let's do something a little unplanned, Logan. Let's go ahead and add one more challenge in for those that just feel like the extra challenge. Let me add another page in here. Instead of having the character X bounce around, replace that. Actually have it be the character's health. Okay, I'm just appending this to the end as opposed to bringing up the red screen and all that good stuff. I'll bring up pause in just a second, but we'll just jump right into this because this is extra. Okay, so what we want to do, instead of having X, put the health. So if it's 100, put 100 there. Now here's the challenge. Make sure that you handle the collision properly. So it should be when 100 hits the side, not when half of it is off the screen like that. Okay, so always make sure that the health stays on screen. So as soon as that drops, it becomes 90. So now we see 90 come up and hit the top, bounce off. Now we're going to see 80. 80 comes over here, bounces off, and we see 70. So the health stays on at all times, and it'll use the color and everything else. And I'd like to be able to easily just change the default health and be able to see, we start out with maybe 500 or 1,000, and it's just going to work. So again, you're looking to create flexible code. Once again, big challenge, pull out a piece of paper, start drawing it on paper first before you attempt to start coding. So with that, now I will bring up the red screen just to let everyone know that they can pause now. All right, so go ahead and pause. Like I said, super challenge. See if you can figure this one out. When you get done, come on back and let's show you how we're doing it, okay? And welcome back. Hopefully that wasn't too complicated for you. Logan, let's go ahead and jump over to Visual Studio.
All right.
And have a little bit of fun with it.
All right, back into the box class. Well, at first it seems easy. We can take our console.write, replace that with health, and run. And there we get a printed number. So, ta-da, done. Except that as the health goes off screen, we get a little bit of a flicker.
Little word wrap there.
And that's what we were talking about with the collision detection. We need to make sure that none of the numbers go off screen because what happens is they wrap around and numbers momentarily appear on the other side of the screen.
That's right.
So that means we need to go into our check wall collision and look at what we're doing for our checks against the right side of the screen. This is the check of if the position is greater than console window width minus 1. Well, we get into values more than 1 now. If our number gets wider, we need to take that width into account. So what we need to do is check the window width minus however wide our current number is. So what do we mean by how wide? Well, that means how many characters would the string of that number be represented by. So that means we need to convert the health to a string and then check its length. So instead of minus 1, we can do minus our health dot toString dot length. Since toString is a method of any object, that makes this very convenient and easy to do here. And let me check off one thing real quick. So that's really all we need to do for the offset. Now, since every time the character potentially goes off screen, we also snap that character back onto the screen. We need to have the same offset in effect here. Otherwise, even though the collision would happen properly, we would then set that potentially off screen. So I'm going to copy this health line down to here, and let's see. There we go. We've got, really, that should take care of it.
It should.
So if we build now, watching for the bounce to not go off screen, and there we go. We just properly bounce off the edge of the screen. So, you were saying we want to do some tests now. We want to test changing the default health to values other than 100 to make sure that our automatic color and now bounce code can handle different scenarios. So let's change it to something significant. Let's change it all the way to 1,000. So now we not only have a much larger number to deal with for the color checks, we also have a wider number for the collision check. So there we go with 100, now down to 998, and there we go. The bounces still work just fine.
And you'll notice it's staying white for a whole lot longer now.
So yeah, it's going to take a while before we reach, so 10 is going to take it to 600. So we have to reach somewhere around, what, 600 or 700 in order for it to change?
We're in the 7s. Here we go. Hang on.
Hey, and then we go to green.
Very nice.
So we're still
So the other system's still working just as well.
And that'll because we have a kind of scaling system set up between our health value and whatever our color's value are. So really both ends of the equation are open now. We can have any range of health against any range of colors and still have a set of colors evenly divided throughout the health.
Exactly.
And we still have the spacebar, so
we're going to throw in
still add some numbers.
Ooh, Fast Guy's going to change colors quick. He's going crazy. Here he comes. There he goes. All right. Well, this is going to bring this knowledge review to a close. Again, the idea of the knowledge reviews is to test everything that you have learned all the way up to this point. Hopefully you've been following along with all of the volumes in the XNA Xtreme class. If you just started with Volume 2, of course we are assuming that you understood everything that was in Volume 1, because with each knowledge review, that means everything beforehand, from the very beginning, is open game. And we did a lot of that here. We used continue, we used looping, and then we used continue with the for loop. We looped in reverse. We did casting, all sorts of things that we have seen in the past in great detail. We have seen them here in helping us achieve the results that we were looking for with these challenges. So with that, that is going to wrap up this video as we watch our last character die off. Here he comes. So hope you guys did good with these challenges, and we'll see you in the next section in a few minutes. Thanks a lot, guys.